Last period, we started a topic from the maths 2, that is a probability of distribution. What we studied last period? We studied that what is a random variable? We consider its formal definition with some examples also. I explain you what is the meaning of a random variable. Then secondly, we studied types of random variable. One is called as discrete random variable. And another one is called as continuous random variable. For the discrete random variable, we studied very first probability mass function, which is denoted by capital P of x assumes value small x. Secondly, after PMF, we studied the problems based on the probability mass function. Now in today's period, we have to discuss what is a cumulative distribution function. Third, expected value of x. And fourth, variance of x and standard deviation. Last period we completed up to the probability mass function. Now in this period I am going to explain you what is a cumulative distribution function. We'll explain by using one or two examples as well. Then we'll have to discuss what is the expected value of a random variable x, and then variance of x and standard deviation of x. So let me start with cumulative distribution function. Naturally, as name indicates, cumulation means addition, adding. Here cumulative distribution function at any point x is defined as it is a sum of the probabilities of all the discrete values of x below the value of x. Let me explain it by using an example. Let capital X is a discrete random variable. Let its probability distribution is as follows. Capital X and their probabilities. Probabilities that x assumes value small x. Suppose that the random variable capital X assumes the values x1, then x2, then x3, then x4, and dot dot up to xn. And let their probabilities are p1, p2, p3, p4, dot dot up to pn. Cumulation means addition. Now cumulative distribution function, or simply we may call it as a distribution function, is denoted by capital F. So how it is defined? Capital F of x is defined that it is a probability of all x less than or equal to small x. That is capital F of x1 capital F of x1, first value of x, is exactly equal to probability that x is less than or equal to x1. Here x1 is the first element, so its probability is p1, so of course it is exactly equal to p1. F of x2 is equal to probability that x assumes value less than or equal to x2. X assumes values less than or equal to x2. So which are the values of x which are less than or equal to x2? Those are x1 and x2. So naturally it is exactly equal to probability at x is equal to x1 plus probability at x is equal to x2. And therefore it is exactly equal to p1 plus p2. F of x3 is equal to probability that x is less than or equal to x3. Means we have to add probability at x is equal to x1 plus probability at x is equal to x2 plus probability at x is equal to x3. So those are equal to p1 plus p2 plus p3 and so on. So this is very simple definition of the probability distribution. Naturally probability distribution is defined for all possible values of x. If we has been given any value which is less than x1, suppose that alpha is less than x1. And if I ask you what is the f of alpha? What is f of alpha? Naturally I should consider it is equal to 0. Suppose that beta is greater than xn, the last possible value. Last value for capital X is xn. If beta is greater than xn, if I ask you what is the f of beta? Of course it is exactly equal to 1, because up to xn the sum of these probabilities will be 1, and therefore probability of a beta must be equal to 1. Well, very first let's write the formal definition of cumulative distribution function, and then let's try some problems based on it. So see here, let's write the definition of the binomial distribution. Let's write the definition of a cumulative distribution function, not the binomial distribution. See here, let capital X is a discrete random variable. Defined on sample space S. Let x1, x2, x3 dot dot up to xn. What is this? This is a range set of a capital X. Let x1, x2, x3 dot dot up to xn is a range set of capital X. This is a range set of a capital X. Let p1, p2, p3 dot dot up to pn are the probabilities of the values of capital X respectively. Of the values of capital X respectively. By considering all these things, now cumulative distribution function which is denoted by capital F of X at any point at any value capital X is equal to small x is defined as capital F of X is exactly equal to probabilities that X is less than or equal to small x. This should be your definition. This should be your definition. I explain you what is this meaning. Let me try some examples based on this definition, see what is the first problem. The probability distribution of a random variable x is capital X assumes value small x and probability that x assumes value small x. Minus 1.5, minus 0.5, 0.5, 1.5, and the last value is 2.5. And their respective probabilities are 0.05, 0.20, 0.15, 0.25, and lastly 0.35. The first problem is construct CDF, that is cumulative distribution function, capital F of x. Second, obtain probability that x is less than or equal to 0.5, probability or capital F of minus 0.5, and lastly f of 2 and probability that x is less than or equal to 4. Let me try the problem here. Very first we have to construct the CDF, capital F of x. So I will have to very first find the function capital F defined on all these values of x. So let me try with the first value. Solution: f of minus 1.5. f of minus 1.5. According to our definition, f of x is exactly equal to probability that x is less than or equal to small x. So f of minus 1.5 will be probability that x is less than or equal to minus 1.5. You can check from the table which are the values of x which are less than or equal to minus 1.5. It is only one value, and that is equal to minus 1.5, and therefore it is exactly equal to probability that x is exactly equal to minus 1.5. And what is that probability? That probability 0.05. So therefore f of minus 1.5 is equal to 0.05. The second one, f of minus 0.5 is equal to, once again see the definition, capital F of x is equal to probability that x is less than or equal to small x. So f of minus 0.5 will be probability that x is less than or equal to minus 0.5. So which are the values of a capital X which are less than or equal to minus 0.5? Those are minus 0.5 and minus 1.5, and therefore it will be equal to probability that x assumes value minus 1.5 plus probability that x assumes value minus 0.5, and therefore it is exactly equal to 0.05 plus 0.20, and therefore it will be 0.25. So therefore f of minus 0.5 is equal to 0.25. Capital F of next value is 0.5. Once again see the definition, capital F of x is equal to probability that x is less than or equal to small x. Definitely you can guess f of 0.5 must be equal to probability that x is less than or equal to 0.5 From the table, see which are the values of x which are less than or equal to 0.5. There are 3 values, minus 1.5, minus 0.5, 0.5. So I will write it is exactly equal to probability at x is equal to minus 1.5 plus probability at x is equal to minus 0.5 plus probability at x is equal to 0.5. So it will be equal to 0.05 plus 0.20 plus 0.15. So adding this 3, I will have 5 plus 5 will be 10, carries 1, 1 plus 1, 2, 2 plus 2, that gives you 4. So therefore it is equal to 0.40. So f of 0.5 will be 0.40. F of 1.5 will be probability that x is less than or equal to 1.5. Naturally the values of x which are less than or equal to 1.5 are probability at minus 1.5 plus probability at minus 0.5 plus probability at 0.5 plus probability at 1.5. You can check it. It will be exactly equal to 0.65. I am writing it directly here. You can understand how I get it. 0.5 plus 0.25 plus 0.15 plus 0.25. पहिल्या 3 संख्यांची बेरीज जर 40 आलेलीच होती, त्यात मी 25 टाकले तर 65 येणार आहे. सो नॅचरली इट विल बी 0.65. अँड द लास्ट वन, f of 2.5 will be f of 2.5 will be probability that x is less than or equal to 2.5, and therefore it will be equal to probability at x is equal to minus 1.5 plus probability that x is equal to minus 0.5 plus probability at x is equal to 0.5 plus probability at x is equal to 1.5 plus probability at x is equal to 2.5. So adding all these probabilities, those must be equal to 1. 0.05, because you know for the PMF sum of all the probabilities must be equal to 1. So our last cumulative distribution function must, the last value of a cumulative distribution function must be equal to 1. Then and then only the problem is correct. 0.20 plus 0.15 plus 0.25 plus 0.35. Adding all these, 5 plus 5, 10, 10 plus 5, 15, 15 plus 5, 20, carries 2. 3 plus 2, that gives us 5. 5 plus 2, 7, 8, 9, 10, 0, carries 1, 1. So that is definitely equal to 1. So probability at 2.5 must be equal to 1. So let's write the cumulative distribution function once again in table form now. I am going to write this cumulative distribution function in table form, such as x assumes value small x. The first function is probability mass function. In short, it is denoted by PMF. Abbreviatively, we denote it by PMF. Of course, it is denoted by capital P. That x assumes value small x. And lastly, we are going to denote cumulative distribution function. Abbreviatively, we denote it by CDF, and it is denoted by capital F of x. It is denoted by capital F of x. What are the values of x? The values of x are minus 1.5, minus 0.5, then 0.5, then 1.5, and lastly it is equal to 2.5. Probability mass function is already given to it. It is equal to 0.05, 0.20, 0.15, 0.25, and 0.35. Now cumulative distribution function will be, it will be 0.05, then f of minus 0.5 will be 0.25, then f of 1.5 will be here it is equal to, sorry, f of 0.5 will be 0.40. F of 1.5 will be 0.65. And lastly, f of 2.5 is equal to 1. At last, we must have 1 here. Then and then only our problem is correct. Otherwise, it will not be a PMF, or our calculations may be wrong. So this is a cumulative distribution function. This is a probability mass function. You can see, instead of solving like this, if you want to write cumulative distribution function in very short, you can write directly here in the table itself. Capital F of minus 1.5 will be 0.5. Then addition of these two, 0.25. Then addition of these three, 0.25 plus 15 will be 0.40. 0.40 plus 0.25 will be 0.65. 0.65 plus 0.35 will be 1. You may write it directly as well. But this is the actual way to solve the problem. Well, this is the cumulative distribution function. Now let's try the second problem from the same question. It is A, here it is a B. We have to obtain the probability that x is less than or equal to 0.5. We want to get the probability that x is less than or equal to 0.5. This is a probability mass function. Well, probability that x is less than or equal to 0.5. Actually, we completed the problem. Probability that less than or equal to 0.5 is exactly equal to f of 0.5, or it is a probability at minus 1.5, probability of minus 0.5, probability at 0.5, and addition of all these will be 0.40. So you may use directly the definition of a CDF. Probability that x is less than or equal to 0.5 is nothing but f of 0.5. And we solved it already. What is the f of 0.5? It is equal to 0.40. Next, f of minus 0.5. We already have completed the problem. F of minus 0.5 is equal to 0.25. The next problem is f of 2. F of 2 is equal to, we do have completed the problem. Rather, see here, f of 2. Actually, it is value in between 1.5 and 2.5. What is the meaning? Actually, according to our definition, f of 2 will be probability that x is less than or equal to 2. So, which are the values that x assumes which are less than or equal to 2? 2 पेक्षा कमी असणाऱ्या व्हॅल्यूज ज्या x assume करू शकतो अशा कोणत्या कोणत्या व्हॅल्यूज आहेत? Naturally, it is minus 1.5. Definitely, it is less than 2. Minus 0.5, it is less than or equal to 2. 0.5, it is less than or equal to 2. 1.5, it is less than or equal to 2. 2.5, it is greater than 2. So we should not take it. So probability that x is less than or equal to 2 is exactly equal to probability at minus 1.5 plus probability at minus 0.5 plus probability at 0.5 plus probability at 1.5, and therefore it is exactly equal to, therefore it will be exactly equal to 0.05 plus 0.20 plus 0.25, something is wrong I think, 0.05, 0.20, 0.15 plus 0.25, and addition of all this will be exactly equal to 0.65. अरे पण तुम्ही चेक करता का f of 1.5 सुद्धा किती आला होता? 0.65 आला होता. f of 2 पण किती यायला लागलाय? 0.65 यायला लागलाय. See here, capital F of 1.5 is equal to 0.65. If I ask you what will be probability, sorry, f of 1.6, probability less than or equal to 1.6. 1.6 पेक्षा कमी व्हॅल्यूज कोणत्या कोणत्या याच व्हॅल्यू घ्याव्या लागतील. ह्या सगळ्यांची बेरीज केली तर किती येणार आहे? 0.65 येणार आहे. What will be f of 1.7? 0.65. What will be probability 1.8? That is equal to 0.65. What will be f of 1.9? It will be 0.65. F of 2, of course it is equal to 0.65. What is the f of 2.1? That is equal to 0.65. F of 2.4 f of 2.4, it will be 0.65. But when I ask you what is f of 2.5, it is equal to 1. It is exactly equal to 1. So from 1.5 to 2.4, 1.5 to 2.4, 2.49, 494, 9999, etc. At every point, the function f is a constant function. And as soon as I reach to 2.5, the value of a capital F jumps to 1. So same thing is going to happen here. Tell me, what is minus 0.5? 0.25. What is f of minus 0.5? It is 0.25. Minus 0.5 पासून ते 5 पर्यंत मी जातोय. मायनस 0.4 ला व्हॅल्यू काय येईल? 0.25. मायनस 0.3 ला 0.25. मायनस 0 ला 0.25. 0.1 ला 0.25. 0.2 ला 0.25. 0.4 ला 0.25. When I reach to 0.5, then it becomes 0.40. So therefore, the function like this is called as the step function. The function like this is called as a step function because in between these two values, the values of a capital F of x remains the constant, and as soon as it reaches to the next value of a capital X, it jumps to the next value, and that's why it is a step function. I will show you how the graph of the function capital X will at the last of the problem, but this is a way to solve the problem. Hoping by using this problem, you will get what is the meaning of a cumulative distribution function. Probability that x is less than or equal to 4 means f of 4. You can see 4 is out of the range of the values of x. So we want to find the probability that x is less than or equal to 4. 4 पेक्षा कमी असणारे सगळ्याच व्हॅल्यूज घ्यावे लागतील मला, आणि मी ह्या जर सगळ्या व्हॅल्यू जर घेणार असेल मी, तर डेफिनेटली ह्या सगळ्या प्रोबॅबिलिटींची बेरीज जर केली तर ते किती असायला पाहिजे? इट मस्ट बी इक्वल टू 1. इट मस्ट बी इक्वल टू 1. सो प्रोबॅबिलिटी f of x less than or equal to 4 is exactly equal to probability at minus 0.5 plus probability at minus 1.5 minus 0.5 plus probability at 0.5, then probability at 1.5 plus probability at 2.5, and sum of these probabilities must be equal to 1.